And what we have to understand about cloning, let's put it this way. When was the first animal cloned in America? 1979. Okay? So with that being the case, and the fact that the technology's there, that they can actually duplicate identically the cell like an identical twin, since 1979, no one has said to date that they've cloned a human. But I'll give you the information here in a minute. A guy from Buenos Aires that made all his money in oil started cloning racehorses, and he started cloning them for polo teams. And the team that just won last year had 6 cloned horses that they raced on. Okay? So it's happening every day. And why did I bring it up? COVID. Okay? When COVID hit and I started looking into all the data, what I found was gain of function. Anybody ever heard the term? Gain of function is when you manipulate the cell to gain function of the cell. All right, everybody have that concept down. So, cloning in humans, and the reason I put down for today, topic of interest is the clone a new you, or identical? Answer? Yes and no. All right? And we're going to get to, through the discussion that we're going to have, everybody will understand where the technology is today. And everybody will understand how we got here. And then ultimately, this is real. Homeo, you guys know my nurse practitioner, Holly? Yep. In China, they have what are called humanoids. And she said I would not be able to tell the difference between the robots and the humans. Is everybody following me? And again, one of the things that brought me to this topic was, what was I doing there? Oh, I was in Florida. Last year, my daughter graduated, and we went down to Florida for her graduation. And long story short, my daughter had to leave at 4:30 in the morning. Not the one that graduated, a different one. So I got up at 4 in the morning, shocked her. I was down in the lobby when she got up. And so we walked out, gave her a hug and a kiss, and the guy that was driving the van said, "You can go with me to the airport. It's only 5 minutes away." So I go with her, come back. As we're driving back, we start talking. And he says, "Yeah, Doc, my family's been in the hotel business for," I think he said it was like 80 years or something. And I said, "Oh, that's great." He said, "Yeah, but now we're all screwed." And I said, "What do you mean?" He said, "Robots. They're taking over everything." And I said, "What are you talking about?" And he said, last night he was at a 7-Eleven, and all of a sudden he heard a crash. And over the intercom it said, "Spill Al 2," and a robot came out of a closet, cleaned it up, and went back in the closet. This was a year ago at 7-Elevens. Okay, so stay tuned. The topic coming up in a couple months is robotics ethical to replace physicians, nurse practitioners, extenders, and nurses? And it's already happening in 17 hospitals in America. And I tell the story, I was at Hammett Medical Center in 1978. And my job was, I used to take all the patients that had their anesthesia and had their surgery, I'd get them back up to their rooms. So they're asleep, and you just hit the stretcher, so you just pull it with one hand. And then you hit the button on the elevator, take them up, get them back to bed. And I'm walking down, and all of a sudden, this little metal thing, like it looked like one of those movies, Star Wars, starts going to the elevator. and gets right in front of the elevator, and all of a sudden the button pushed as if the thing pushed it. And I just stood there. The elevator opened, it got in the elevator shut, and it went up to the floor and gave the pharmacy their medications. That was in 1978. That's the technology. That's what we're in the middle of. And that's what prompted me to think, okay, what's going on with cloning, what's actually happening? And I'll run through the physiology so you guys will understand it. So today you're going to have a test. You have to have a test because this is a lot of information. All right, so what do we understand in order to figure out what's happening? Genetic code. What does that mean? Does everybody know the term? I'm going to teach you it today, but has everybody heard of messenger RNA? You guys haven't heard of that? Oh, good. We're going to learn all kinds of stuff today. All right. The genetic code is what we are duplicating with cloning happens naturally. Okay? In human beings, there's sexual intercourse that leads to a sperm and an egg uniting. And those two, once they unite and start to duplicate, is what we end up with. The messenger RNA comes in. And I'm going to draw it. They call it a helix. I'm terrible at drawing. But everybody gets it. It's a curved, and it sits inside the cell. On here, they have proteins called nucleic acid. And each one of these codes for a gene. Is everybody with me? So the chromosomal makeup of our bodies can be found on the inside called a buccal mucosa. So if you ever watch the police movies, they tell the person, like, we want to get your DNA, so we're going to swab your mouth. So swabbing the mouth and taking the embryo of a newborn baby, we can make organs. Does everybody follow me? In the lab, just getting the mucosa of your mouth and the embryo from the baby, you take the blood out of there, and what we're looking to do is get the stem cell, S-T-E-M. This is our anatomy lesson. Stem cell. What are stem cells? They're what's called pluripotential. What does that mean? Remember, the DNA is in every cell in our body. Billions of cells. Okay, why does that DNA... Sorry guys, that's probably my bookie. Why does that DNA make the skin a certain way, the fingernails a certain way, the hair a certain way? That's all the proteins in the body tell it what to do. And it's specialized proteins that make who we are and how we are. And I think the data that I read said since 2008, it's pretty commonplace if you're a Californian about to have a baby, that you pretty much decide what you want the baby to be. So blonde hair, blue eyes, 6 foot tall, like all those things. You can actually now, the scientists in the lab know what part of the genome is hair color, eye color, body habitus, all those things. And so you can pretty much go in and pick out your baby nowadays. And it happens regularly in California. Okay, so what happens now is we know the technology, these pluripotential, what does that mean? That means this stem cell potential is more than one. Okay? Where we learned it first was in the body's bone marrow. When I was in medical school, I found it was unique that when you looked at the cells under the microscope that were immature, all those cells were headed to 3 different lines. Your white blood cells, your red blood cells, or your platelets. And where they start, the genetic material inside them could make any one of those 3. If you stimulate it in the bone marrow, they rapidly develop. And when I first heard about it was my mother had colon cancer, and the chemotherapy hurt her bone marrow, so she had to get blood transfusions all the time. And so back in those days, it was a real PIA for her. And ultimately, they came up with different type of bone marrow stimulating medication. And there's many on the market today. What that means is you get a shot, and it stimulates your bone marrow to make more cells. And so it saved her from getting 2 transfusions a month to 2 transfusions every quarter. Unfortunately, over time, even the medicine didn't work. But again, this is going back to 1985, 86. So the technology is fantastic when it comes to stem cell and cloning. And what we have is, we have 3 basic ways. We'll put cellular, organs, and therapeutic. What does that mean? Has anybody here had a stem cell shot in their knee for arthritis? Don't raise your hand. I did one, and it was great case. How's this all work out? My younger brother is a sports medicine doc, and he's the medical director at Mercy College in Erie. And so all the sports teams, because he's sports medicine, he knows all the patients or all the kids playing. What happens is, let's say a basketball player twists their ankle. All right, a twisted ankle in a basketball player could mean no scholarship or scholarship next year because they'd be out, sprained ankle, especially if it's a high ankle sprain, for 2 weeks. Injecting stem cells into that sprain, they're playing in 2 days. Does everybody follow me? The stem cell is pluripotential, so where are you putting it? By the muscle, the cartilage, and the tendon. And so it heals it right when you inject it. Does everybody follow the concept? That's what's called therapeutic. What are organs? Just like it said, guys, the guy that the guy that's done the most research, he's the guy that has the 6 horses for the polo guy, and he's the guy right now this close. I'll bet he has made humans already. Because people in the lab, they don't write down what they're doing every day. They write their findings after 10 or 20 years. And the fact that he's on the verge of everything right now in all the literature, I'll bet he's made some humans that are running around someplace. That all being said, this guy now, with this technology, what he has is, first place you have to show it is in the lab. Let me give you an example. I'll go through the history. 1979, mouse cloning for the lab. No one said a word, right? Because it's mice, we need mice, we give them all the disease, we figure out what's wrong with us. Okay? Second one, 1996, Dolly. Anybody ever hear of Dolly in 1996? That was the first sheep. They cloned a sheep. Sheeps normally live 12 years. Dolly died in 6 years. And when she died, she looked like she was 40. Does everybody follow me? So that's the lead part of what I was going to say. I already gave it away. Is the new you identical? Not at all. I mean, it has a lot of identical features, but it's not identical. So in 96, that was Dolly. The next one occurred in 98, and that was not a sheep. What was it? Cow. It was a cow in 98. And then in 2000, there was Reese's monkey, which was very important because it was in the primate now. So it got into the primate, and again, for the sheep, it took 277 embryos, and of the 277 embryos, they found maybe 60 were viable, and of the 60, 1 lived, Dolly. Does everybody follow me? So in the lab and getting these embryos, which you have to get from these animals in order to try these things, it's not a perfect science at all. And so what you find, just like human nature, what happens every month with women, the ovaries produce an egg and they send it down the fallopian tube with the hopes that it gets conceived with the sperm cell, right, and becomes a baby. But All those other potential babies that don't get fertilized, that's the menses every year or every month. Does everybody follow me? So some people, when they hear, wow, you're destroying 277 embryos and you're taking these out and only one lived out of 277, that's not necessarily a bad thing. That's the pros and cons of cloning. Okay, when I say it's not necessarily bad, human nature, all those eggs every month that potentially could be conceived are not every month. It depends on if there's sperm there or not. So that argument we'll get back into, but my whole reason of bringing it up is the technology has advanced so fast, guys, and where we are right now with that technology, that's why I wanted to bring it up. Okay, so let's get back towards more of the physiology so you see how I got into it with COVID. I didn't tell you cellular. That's the first part of cloning. When did that start? Insulin. How was it done? Bacteria. What does that mean? You guys know what a petri dish is? It's a little dish that we put germs on and you let them grow. Okay? And it's what's called an agar plate, which is blood, so all the nutrients it needs to grow. Bacteria will divide, just keep dividing. And so where they were able to, it's called monoclonal, they cloned this particular, in this case, it was insulin. And that's how they managed to get the insulin. So it's human insulin that we're giving now, not the cow or the pig insulin. Does everybody understand the concept? Okay, so what happens now is we have cellular, organic, and therapeutic. Organ means like you're able to develop, say, a liver. The guy that did it, I'm going to spell his name wrong, Maltipov. Okay? He was type 1 diabetes. What motivates people to get this kind of technology to move this far? Type 1 diabetes, you are born without the ability to produce insulin. So you take shots all your life. And it's what's called juvenile in the old days. What does that mean? Usually women before they turn 10 and men before they turn 12 have symptoms and problems related to the sugar, and they end up finding out they're type 1 diabetic and they need insulin every day. And the technology with insulin, back in the 50s, all the way through to now, where they can put that pump in and they regulate it. You just fill the pump up every month and the pump gives you the insulin that you need. So the technology advances based on the need, and that's again where the organ component became the issue, because do we really now produce a bunch of pancreases? So the people that have type 1 diabetes, we transplant the pancreas with them. I worked with the transplant. I spent 2 years with the Pittsburgh transplant with Dr. Starza. We transplanted livers, we transplanted hearts, we translated all kinds of things. So I know the technology, I know that it works, and if you donate your organs when you pass away in, unfortunately, an accident, I used to run that team, where I would see one body, the people got the eyes, the people got the skin, they got the bones, they got the pancreas, they got the liver, they got the kidneys, they got the heart. So technically, there's needs. That's where the organ part comes from. So now, can we produce, let's say you're waiting for a kidney. Can we take a buccal smear of your mouth, take a stem cell from an embryo, and make you a kidney? Answer, yes. Is it being done right now today? Unfortunately, yes, but it's a black market way. So where we are right now is many, many things are going on. Now, once again, I want you to understand the physiology, if you will. So we have a cell that's human from an embryo or your mouth, and what we're trying to do is make that cell divide. In comes the stem cell. Does everybody understand that? When that baby's born and they're delivered, the placenta, when they take that cell from that placenta, that's still alive from the vantage point of it's the afterbirth of the natural birth, and they have those cells. So these cells now can divide because they have a blood supply. And so what they do is, based upon what organ that they need, they get cells from the donor, and once they get those cells, they can put in specific proteins. Remember the genome? Remember that? It's called a histone. This is the genome in every cell. And now they've been able to identify, remember California, I'll put California, the eyes, the hair, the height, all those things could be determined. So they take the stem cell, this particular guy wanted a pancreas. So they can actually produce a pancreas that can be transplanted into the human body if you are the donor. Your mouth cell, your cells from your mouth. So everybody understand that? That technology's out there. So we have organs, and we have that you can use therapeutically. How? Like I said, my brother gives a shot and gets them back on the floor. Now, what about the cellular one? Anybody heard of the PCR test? Right? That's the test for COVID. What happens? They take a portion of the disease, in this case, COVID-19, and that genetic material of that COVID-19 produces a protein. So that protein, once it's produced, they can, again, through stem cells, regenerate those proteins. So what are they looking for? They swab your nose, and they see, do you have a matching protein in your body? If you do, and it identifies as the COVID-19, you're positive. Does everybody understand the concept? So then when I heard of gain of function, I looked into, well, what is the situation that is going on with gain of function? And what they talk about is, remember, on that genome that we've been doing since 1979, we've identified where the eye color comes from, where the hair color comes from, where everything comes from. So we know all aspects of it. And all aspects require proteins. So they're able to identify the protein and manipulate it. What does that mean? Just what I said. Manipulate it. What are you doing? Stronger, weaker, adding something, changing something. All those different variations lead to another species. Everybody understand the concept? Okay? So we have, as I'm reading everything and I'm researching, I'm thinking, wow, there's a lot going on that no one's really talking about. And so where the technology is and what's happening with the technology, I think we want to have an understanding of it. And that's why I came up with the talk. Okay, so hopefully you guys understand. Again, remember, the stem cell is pluripotential. Getting it from the embryo is the best. Well, my brother, who does sports medicine, thought about it, and he heard of prolotherapy. What prolotherapy is you take your own blood, spin your blood down, and you get a protein out of your platelets. And that protein in your platelets, injected into an inflamed situation in your body, whether it's a knee, whether it's a hip, can stop the inflammation. What's his objective? Get those kids back playing sports as fast as they can. Everybody understand the concept? Okay? So you can get it from that embryo. Where else can you get it? Your own bone marrow. Remember, we talked about pleural potential. The cells, stem cells in your bone marrow can develop into any cell at all. That's why it's called a stem cell. How do we know it works? Medicare pays for it. Okay? So Medicare will not pay for you to get the embryo. That costs you a lot of money. The shots I was given, they were usually like $2,000 when it first came out. But it worked. That's what was amazing. Okay? So if you go the embryo route, if you go your own platelets can be spun down. That's one way. And then the other one is bone marrow. Anybody have a bone marrow? Don't raise your hand, but if you did, they hurt. I used to do them. Peripheral blood. They put the little needle in, take the blood. If I do it, you don't feel it at all. Okay? When you do the bone marrow, what does that mean? You're getting the marrow of the bone. If anybody's ever seen a dog chew a bone, when they bust open those big steak bones, that's the marrow. That's what we're getting out. That's where the stem cells are. So Medicare will pay for you to get the stem cell out of your own bone marrow and let it be manipulated to put into whatever area of your body that you're going to put it into. Does everybody understand that concept? That's happening today. My brother probably does, some of his clinics are busy. I'd say in a week he probably does it 100 times. And that's either the stem cell or the PP, the one where you take your own platelets. Okay? And again, what's it used for? Athletes. That's what he's in the middle of. And all these athletes, when they do a program up in Erie, I forget what it was called, Family something or other. It's this huge complex. Like the complex has like 12 basketball courts in it. And if anybody's seen a basketball court, it's almost this size. Imagine 11 more of these in that space. His waiting room had a basketball hoop. I used to like going in his waiting room and just shooting baskets. But the bottom line is, what it comes down to is, technology has advanced and used these things for cellular therapeutic use, organs for transplants for people that are looking for organs. I don't think any of us would argue any aspect of that is quote unquote necessary. All right? Now we step over into the other realm. It's amazing. I didn't know this. Sharks, amphibians, lizards, and I forget the name of the fish. There's a couple different fish. Can reproduce without a male. And they do it regularly. Video it. They show sharks reproducing, where they'll show the shark, they put him in an aquarium, and they watch him for a period of time, and all of a sudden, a baby comes. And so what happens is asexual reproduction occurs in animals in the world today naturally. What does that mean? The scientists study to see how that happens, right? And those studies help them find, in the terminology, you'll appreciate this, it's called epigenetics. What's epi? On top. Above. Well, what does that mean? Remember the helix. This is where it comes in. Is your clone identical? No. Why? Because of epigenetics. What does that mean? Remember, I told you these are all proteins. And it's adenosine, cytosine, guanine. These are all the proteins in the body. And what happens is they have to read this. So this is the DNA in your body. And it goes to mRNA, tRNA, and what's it called? It goes to the organelle ribosome, ribosomal RNA. Okay? When you're in medical school, the way you remember things are what we call mnemonics. Okay? So mnemonics, I'll give you one. The 12 cranial nerves. On old Olympus, towering top, a fin in German vaulted a hedge. And that tells you all the nerves. So that's how you remember things, okay? Well, also what happens in medical school is we find ways to envision this. So imagine the DNA is going to completely, identically go into another cell. How does that happen? That's the beauty of genetics and embryology. And again, they've investigated this for so many years, they know all the proteins. So here's how I was taught to remember it. It's so cool, guys. See if I can draw well enough that you guys will remember what I'm showing you. I don't know if I'm going to be able to do this well. Nah, I already think I can't. These are the old tape recorders. You remember the old tape recorders? You push the button and that little white piece hit it, right? You guys remember that? Okay. This is how I was taught RNA and how to remember how it all happens. Okay, so what's the messenger RNA? The messenger RNA is what's on the reels. Okay? What's the transcription RNA? Transcribe, right? Think of that little white thing touching now that tape of the tape recorder. Okay, does everybody follow me? So the messenger RNA is on the reel, and now that little white thing touches it and transcribes everything that was on that reel. Where does it go? It goes to the ribosome, which in a cell, this is the cell wall, this is cytoplasm, and this is the nucleus. Ribosomes are what make up the majority of the cytoplasm, and they're housed with proteins. Okay, so this is what we got when I was in medical school, that the professor of embryology told us. Just remember, the messenger RNA is the tape on the machine. The transcription RNA is that white little cottony thing that touches it, and then everything goes to the ribosome. And the same thing happens in our bodies. That's how we make an exact copy. When that cell divides, it's exactly the way the other cell was. It's called meiosis. Okay? And what it means is the exact duplicate RNA, DNA is in that other cell. Does everybody follow the concept? So now where we are. We're now at the point where messenger RNA gets transcribed with RNA, and in the ribosome, or rRNA, it makes the identical DNA. Okay? So this, for me guys, that's why I put it up there, because that's how I can remember the concept. What you want to now recognize is, if you manipulate the cell for gain of function, the messenger RNA, let's just say, is the leader. Does everybody follow me? So I want you to have that concept in your mind as we move forward, because to understand all this stuff, you want to know, how does the body make every cell perfect? And then what happens with cancer and mutations, we'll talk about in a minute. But that's what happens. Instead of it being perfect, there's a mutation that occurs within that genome, and that protein becomes abnormal. Okay? Real quick, back to the epigenetics. So what happens is the epigene enables the messenger RNA to read the DNA structure. And what can happen is, even if you have identical cloning, so you want to clone yourself, you can still have, because of the epigenetics, you can still have differences. What does that mean? That it won't be like a identical twin. And of course, if you clone yourself, you're at whatever age you are, the baby is going to be born and then has to come up to an age where we are. And the technology, when you read the guy that's doing all the stuff, what they talk about is being able to clone the brain to have all the information that's in the brain and keep all that information around. And the way I saw it, it was all done animated, of course, but the way I saw it, it was like there was almost like an aquarium, and that was Grandpa. And so anytime you wanted to talk to Grandpa, you could talk to Grandpa because he was still there, because his brain was still being kept alive with the technology we had. And he would tell you stories. That was in what I watched, just to get the concept of all this. All right? So I hope it's a lot of information, guys, but the reason I'm making sure we understand at least the concept, this is going to come out fast. In the next, I'd say in the next 6 months, you're going to hear a lot about this stuff. Plus, you're going to hear a lot about med. This is the talk coming up. I think I'm doing this one in October. MED, med beds. If you haven't heard of them, they're the new technology that's out, and it has to do with vibrations. And the vibrations that occur within our body can manipulate the gene. Does everybody follow me? So, is there good therapeutics out there in cellular activity? Sure. If you find the mutation that causes the defect that leads to breast cancer, like the HER gene, that's what it is. The scientist in the lab figured out, like, wow, if that gene is expressed, what does it mean by expressed? You have all these genes, but which one's more dominant? If it's mother and father getting together, you may look like your mother, you may look like your father. Okay? Or you may look like Uncle Charlie or whomever. But the bottom line is it's genetically in your whatever, right? The genetic makeup, your genealogy, all those kinds of things. Okay? What we started doing this for, remember what I said, this guy was a diabetic. That's what had him interested in there has to be a way to make this insulin. And he's the guy that figured it out. Just like, I don't know if you guys ever heard the story, there was he was some kind of engineer. He had Hodgkin's disease, and he came up with the radiation treatment. He thought, there's no way I'm going to let this thing kill me. And he talked to his doctor about, kill it with radiation. Well, how do we know where to go? I'll figure that out. Just kill it with radiation. There's a guy from Pittsburgh. But the bottom line comes down to, why do these people think outside of the box to get to the point where they have these, their imagination takes them to these places. And once again, this guy did it related to, he had to shoot himself with insulin, and he thought, man, wonder if I can make a pancreas and put a pancreas in. And along the way, the guy's produced so many horses you can't imagine. And look it up. Google it, the cloned horses. Because the guy's a polo guy that they were all saying the guy that made the horses was crazy, that's ridiculous, these horses aren't going to be as good as the other ones. Well, what did he do? He cloned the racehorse 6 times, and in the last polo game, this guy rode all 6 horses in the match to prove to everybody out there that these horses were as good as regular horses. And they won. Okay? So Google it, you'll see it. But what I want to make sure now is the understanding of the technology, where we're going. Because we can pretty much manipulate anything to do anything. All right? So, the technology has advanced that we now understand the genome, the DNA, and RNA. The terminology is what we call sequencing. And we understand that there's therapeutic reasons, there is organ, and there's cellular. And this is all with the cloning. All are good. But with the organ, and with this guy, Multipov. I can't say his first name, begins with an S. Okay? With this guy's money, I forget the amount of money, millions of dollars he spent to be able to clone those horses. Because nobody wanted any animals or humans recreated. They wanted to leave that out of the equation. But once this guy proved this, and now that he's able to get organs through the genetic, technology of cloning, he's making cases. I mean, if you're sitting around right now, and I actually have 2 patients that are looking for a kidney, and I have a patient that's looking for a heart. If the technology is there and it can be advanced in such a way that it's not only going to be for the rich, and if you're able to clone your own body's heart, the chance of rejection is a lot lower. Plus, what they also found with the cloning is the environment has a lot to do with how well they do. So this same guy that did the horses, he has them at the best stables, getting the best exercise, and he's proved the 6 that were cloned outperformed the original. Again, that's where the whole mindset is going, guys. Like, if we're able to make humans, and we're able to make horses, and we're able to make sheep, and we're able to do these things, where's everything going? And again, the reason I said about, is it identical you? No. The upside, or let's say the pros, I would say medically, medications, identifying disease, big pros. What's the cons? Aged. To date, we haven't figured out how to stop the aging process, and so all of the animals, like go back to Dolly. Dolly was the original sheep that everybody talked about in 1996. Average length of life for a sheep at that time in 96, 12 years. She died at 6 years, and she looked very old. So we haven't figured out, once you make whatever you're trying to clone, how to make it so that it doesn't advance in age rapidly. How do you do that? Scientists will figure it out, guys. It's all in the labs. That's what they'll come up with. All right? And then the other thing is, I put ethics. When I first read it, I was like, come on. And then all of a sudden you see the world where it is today. Like when I first read it and you hear that this guy's 6 horses are better than the original one, well, what's going to happen now if you create another, what do you want to call it, race? Like another group of people that are different than us because they're made in a lab. Well, the people on the pro side say, what about test tube babies? We all talked about that. You know, whenever you take the egg of the mom and the sperm of the dad and you, in a test tube, get them to divide, and then you implant those into mom. That's manipulating life. But once again, they're saying, no, they stayed in mom for that whole term, and they were born naturally. So no, that's not the same. This is now taking a swab of the inside of your mouth, mixing it with your stem cells, and coming up with another you. And ultimately, this is where we're going to get to. And how is that now coming to be? One of the reasons I brought it up, guys, is some of the horrific stuff you hear and some of the good stuff you hear, but ultimately, it changed what I thought about a lot of things. I was at a wedding 2 weeks ago, and I sat at the table with a personal friend of mine. Her name is Leah. She's the CEO of Encompass Health, which is an inpatient rehab. And we were talking about this. We were going through a lot of different stuff. And she goes, where you been? I said, what do you mean? And she said, Dr. Demas, from 1980 to 1984, did over 200 sex change operations at Divine Providence Hospital. 80 to 84, over 200. It's now 23, so 40 years old these people would be, right? Everybody follow me? So we're making changes, and all these changes that are occurring, I was unaware of. I had no idea that that happened in the 80s in Pittsburgh, let alone Divine Providence Hospital. And now let's say, prepubescence receiving hormone manipulation. And the scientists know why sharks, lizards, snakes was the other one, that if there's no males around, they can asexually reproduce. And again, it's a protein that stimulates the genetic material to divide inside the mother. But what's going to happen? These are reproduced species without sperm or the father. So what does that mean? Stay tuned. They're studying it. That's what's going on. But we're seeing the whole world change right now. Is everybody following me? That's how I got into the topic, guys. When I heard that we're manipulating cells of viruses to gain function of the virus, so we're manipulating the cytoplasm and the nucleus, what ultimately is the end game, or what ultimately is the benefit? Well, when you see the scientific benefit that the researchers do and the scientists do to come up with treatments, fantastic, 100%, I'm all for it. But in the process, do we do any harm? And I don't think we've seen the data yet. Why not? I don't know. I tell the story, 1998, if anybody's been to my McKnight office, right across the street was Chi-Chi's restaurant. In Chi-Chi's restaurant in 1998, on a Wednesday, they got hepatitis. And they found out Friday, less than 48 hours from when it was identified, that it came from lettuce in Brazil. 1998. Do we not know really what happened that COVID hit the whole world like it did? I just leave you with that thought, guys, because it is what we're talking about here. That's how I got into it. When I was seeing like they're doing the PCR, and the PCR is testing for the protein, and the protein is kind of like the same SARS virus that was out in the Middle East. And when you see all this stuff and they're in a lab doing different things, then you think, wow, where's the technology? And like I said, when I looked into the technology, I was blown away. I had no idea that they had this to the point. This guy can make humans. There's no doubt. He even boasts about it, that he has that capability, that the technology has advanced to that point. And he already proved by putting these cloned horses in this polo game and outperformed everybody else. So now that all that's out there with him, pay attention, because all this stuff that's moving, it gives you a different perspective. And that's all I want people to have as we maneuver through the process. All right, now, back to actually, I think it was my first page. That'll be easier. Is the clone a new you? So, let's just say I'm so wonderful, my kids love me, and they decide for my birthday this year they're going to clone me. Okay? So, first and foremost, what we've learned in California, you can manipulate the genome. So, maybe there's things they don't like about me. I can't imagine that. But they would want to manipulate that genome so that I wouldn't have those traits or characteristics. Does everybody follow me? Okay? What if they decide, nah, Dad's perfect, let's just clone him and we'll have another dad? Okay? Primate, Reese's monkey, was not identical. So it's not going to be identical you. Is it going to be very, very close? Yes. And once again, guys, with all the stuff that when you read all these things and you see what's happening, I just can't imagine that someone hasn't done it somewhere. You know, I just think it's happened before, and what we're going to find out is the ramifications, the ups and downs, and sideways part of what is cloning in humans like, and what's it going to be like, and how are things going to be. And again, what's interesting from my vantage point, I thought about it because I had her here a couple lectures ago with Joanne, and I was like, man, I'd love to clone her. I mean, if I could clone Joanne right now, life would be wonderful for me. And my boys are just finishing up medicine. It would be perfect. I had her for 30 years, give them one of her for 30 years. But then I think about it. she's tough as it is now. What if she became tougher? Then what do you do with her? You know what I mean? Like, that's the other part of it that they talk about, the cons. You know, this is all in the lab. We don't know. What is going to happen? We don't know. What does the environment have to do with your mental capacities, capabilities, and ultimately your behavior? All those things are unknown. And that's why the people on the con side of, we can't let this happen, that's why they're there, because they're saying there's not enough information, and even though they won't be humans as we know it, they're going to be people. And so what are you going to do with them? And I actually think if I can get Lee to teach me, I might actually hook up to the computer for the next couple lectures, because it's pretty phenomenal when you see some of the graphics of what they're showing and the technology and what it's already done. I mean, even down here at AGH, they're showing artificial knees. And like, you know how they have a prosthesis that it's just like a little pull? Now they can actually produce skin. Like, they can put skin on this thing. So now, you know, if you're in shorts, you could be walking around with a fake leg that looks like your leg, because it's a stem cell used to clone everything on your left side, now to put on your right. So again, guys, the technology's out there. For me personally, like I said, I find that I've worked with research. When I was down in Texas, I worked on the morning after pill. It wasn't me working on that. I was just trying to get a job when I was in Texas, and I was studying to pass the boards to get back to America. And at the University of Texas in Houston, we had sheep. And what they were doing was they were trying to test to see if you overloaded the body with hormones, could you get the sheep to abort? And the answer was yes, and it was simple. And now what happens? Now the morning after pill is out there. So it's just like an abortion. And that was back when I was down there in '80. And so from research to like the test model or the pilot to being out on the shelf, it used to take a lot of time. What got my attention with the COVID was it was emergency use when it came out. And then I wanted to see, based on what the information was out there, and it all comes back. Remember what I showed you, the messenger RNA. You know, it shows exactly what the DNA looks like, and then the transcription RNA has to take like another picture, if you will, of it and send it to the ribosome. But that's where the gain of function was being manipulated. Does everybody follow me? So the technology that's out there has many, 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 many good things, guys. I can't overemphasize. This guy has diabetes. This guy wants a new pancreas. All the stuff he did with the horses, where he is with the actual humans is pretty amazing. A lot of the work's being done in Portland, Oregon. So if you want to Google it, hit Portland, Oregon cloning, and you'll get all this information I just provided you, because it's pretty remarkable when you look to see what we understand. But again, back to the therapeutics, I'm all for. I worked with the transplant. I saw people's dejection when they couldn't get an organ. I've seen them pass away because they didn't get the transplant. It's horrific. I have a personal friend right now. He was a fraternity brother. He has an LVAD, which is a left ventricular assisted device. And he's probably only got another 3 or 4 months to get a heart. And if there's not a match, he doesn't get the heart, and he's not going to be here. You know, the ejection fraction, they talk about the squeeze of your heart, normal 60 to 65. He's at 9. And that's why he has the LVAD. And so again, for someone like him, love to see him be able to get a heart the way the technology is out there now. But again, equally on the pro side, now we go to the con side. And what are the cons? And again, think about it. If you guys watch any football, I thought one of the best Hall of Fame speeches ever given, if you have a chance, Google it. Rod Woodson. Rod Woodson was a safety for the Pittsburgh Steelers. He and I were in a bachelor auction. I was single. I was at McKeesport Hospital, and I was on the board for cancer at the time. And so we decided by raising money, we would have a bachelor auction and use it as a benefit. So we got Rod Woodson, Dwayne Woodruff, and he was a running back, Merle Hodge. And then I was there, and it was so great because they hadn't even been to preseason yet. And I looked at Woodson, I said, "You're going to be a household name in America." He's like, "Yeah, I wish." He was fast. He was like 4.3 speed back in those days. You never heard of that. Well, as it would turn out, his daughter and my son went to St. Sebastian's together for 8 years. He ended up marrying a girl from the North Hills, and we went to the same church. And the reason I bring it up is he did some of the first knee experimentation with the platelets, and that's how he got back in the Super Bowl. But once again, you know, to get some of the things that are out there now, you have to have the dollars. By the time it trickles down, it's going to take some time. And think about the world today, guys, how everything is changing. What I don't like is hormone manipulation before puberty is permanent. Does everybody follow me? It's permanent. So if you're a girl and you start taking testosterone and you shut off the estrogen, it's not coming. And once again, when they're talking about the age groups and stuff, that's what I got interested in that led me to look at this. And then when I looked at it, that's why I put the topic as it is. If you clone, is it an identical new you? We'll get there, I'm sure eventually. But today, the technology's not there. And today, no matter what you read, they will say there's not been a human cloned in the world. There was a lot of countries, as soon as the technology came out, they banned any kind of cloning in the country. You know, America isn't one, Canada isn't one, Europe, England isn't one. And like I said, the big stuff is Portland, Oregon, is where you'll find all the information on cloning. All right, guys, I leave you with, I feel that the healthcare industry is still the best that it's ever been. But the one thing I have to tell people about, and of course you don't have to worry because you're up here on this campus, but for friends and family and people that you know, regular government Medicare issued by the government, you don't need referrals, you don't have co-pays, and you don't need anything but a slip from me. Meaning, let's say, God forbid, you walk out the door, you fall, and you hit your head. I can write CAT scan of the brain. You take that and go get a CAT scan right now. You don't need a referral. You don't need anybody's approval. You don't need any authorization at all. And the reason I'm so adamant about that now is I have a patient, it was the last week of June, and I found a mass in his abdomen. He's getting biopsied in September, and this is America. It bothers me. And that's what I want to leave you with is make sure you know. You don't have to worry. You guys are here. We have everything set up. If you go to the hospital, we get you up on the hill, get you back to the highest level of function you can get to, so you have everything. Those that don't, and they go to the hospital, if you don't have regular Medicare, everything needs to get authorized. So I don't have any say in it. I can say, I've known the person for 30 years. This isn't them. They need this, 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 and this. Some doctor in Virginia is making the determination. So please pay attention to that. Pass that along to anybody turning 65, you know, to make sure that they get the information. And make sure they ask these 3 questions. Number 1, if I go to the hospital, do I have any out-of-pocket expenses at all? Number 2, I'm in the hospital and they tell me that I can't go back home. I have to go to a post-hospital facility. Do I have any expenses when I go to the post-hospital facility? And number 3, if I'm in an accident or an injury, God forbid, in another state or even another country, do you pay for all the services without co-pays or deductibles? The answer to those 3 things, if you have regular Medicare, is yes, yes, yes. You don't need a referral, you don't need authorization, and they pay wherever you are. I had a good story. I had a patient, he wanted to ride an elephant, right? So he goes to Japan, he's at some, I think it was like a zoo, And he had pictures of, they get the elephant to get way down, he climbs on, he got to ride an elephant. He was all excited. So he goes out, what do they call it? Their drink. Not hashi. I forget what their drink is. It's an alcoholic drink. He said it tastes good. So next thing you know, he's drunk. He falls down some steps. He goes back up to bed. He wakes up in the morning. He can't move his right arm. So he calls 911 or the equivalent over there. They put him in an ambulance. Every ambulance in Japan has hyperbaric oxygen chamber in it. Pretty remarkable, guys. Because if you have a stroke, either a bleed or lack of blood, what happens? No oxygen gets to the brain. This guy's perfect. No complications. If he was in America, complications. Once again, makes you think. And that's what leads me to a lot of these topics, guys. So sorry I was late, sorry to hold you up, but please pay attention. Pay attention to what's going on in the world. Because it's no accident this technology has advanced to this point and we're where we are. That old adage of know-it-all, I think the scientists pretty much know the body now pretty well. And again, those of us that believe that there's a higher power someplace, they're seeing how hard it is to do these things. That's what I find fascinating. You know, like we talked about for the sheep, 277 embryos to eventually get to one live birth. So it's so hard to produce what the human body and animal bodies are capable of doing. Any questions, guys? Yes, ma'am.
Hardly a day goes by when I don't get a couple calls from Medicare trying to sell me more insurance.
Sure.
Your take on that?
SCAM. It's a scam. Don't let anybody in your house. You have a doctor. When they call, be polite. Don't be rude to anybody. It's like, thank you, but I have a PCP. I'll wait and see what the PCP advises. And bring it up to your PCP. But the calls you're getting show you, why are we getting phone calls? Why are there all the commercials? I tell the story. It was in 1998. I lectured down at the Westin Hotel. A friend of mine had me on the panel. It was Highmark, UPMC, 2 hospital administrators, and me. And they put me last. It was their fault. And all these guys talked, and when I got up, I said, everything they just said, I don't agree with any of it. And I got an ovation just for saying that. And I went, this was 1998, and the laws changed in 83. Pre-1983, 98% of hospitals were non-profit. They could not make a profit. In 1983, they switched to being allowed to make a profit. In 1998, and it was really cool, it was the committee, what did they call themselves? They were all chaplains. So they were all over the world, they were chaplains. And I got a from the audience. The amount, 1998, the amount of money spent on commercials and mailings for Medicare could insure the world in 1998. And that's all you hear. And then the hands went up. They wanted to ask me questions. And they're all going, what do you think the problem is? And I'm going like this. And it was. That's the problem. What they did, when doctors, here I tell this story all the time. 1990, September. I have office hours on Tuesdays and Thursdays at night. 9 o'clock. Lock the door, taking my coat off, and there's a knock at the door. I open the door. Little Dorothy Birch, you know, her husband, 6'8", he was the turnpike commissioner. And she's like, something's wrong with Al. So we sit him down, he starts coughing up blood right in my office. So I call Terry Obringer, who's a friend of mine, a pulmonologist. I say, Terry, I need a bronch. I meet him down at St. Francis, first hospital I closed, okay? And when we get down there, he bronchs him, finds cancer. The next morning, George Pavlik gave him chemo. So in 1990, we diagnosed and treated lung cancer in less than 12 hours. Why does my patient have to wait till September to get a biopsy? Does everybody follow me? So the technology that we're talking about, the advancements, the monies, and all the things, and here we are back in 1990, doctors practice medicine and we made decisions. It's now not up to us. But long answer for your story is, please pay attention to what you say to anybody that talks to you. I had a patient this week, and the comment to me said was, I think I would have committed suicide. And I said, don't you dare ever say that ever again to anybody. And the patient got all upset. I said, you can't say that anymore. I know she's not going to kill herself. I know that's never going to happen, but you can't even say it. That's the problem. Everything that you say is part of your matrix. That's a computer-generated information on you. And they now have your genes. If you had a swab, they have your genome on that matrix. So they have everything about you. So there's something about you that someone's trying to sell you something. So when you get that phone call, be polite, don't be rude, but tell them, I will check with my PCP. That's always your answer. No, I don't need a visit from the nurse practitioner. I see my PCP. Because I get that one a lot. Dr. Coppola, they're calling me. They say that my insurance will allow them to send out a nurse practitioner for a free evaluation. As soon as my patient's here free, it's like, oh yeah, bring them in. And then they don't realize what they tell the people. Like the questions that they're asking you, I don't want to be rude and ignorant to any insurance company, but from my vantage point, if they're coming into your house uninvited by your doctor, they're selling you something. And so when they're coming in, pay attention to what you're saying. Listen to the question. Actually, don't let them in at all. But if someone's asking you things, be careful what you say, because it really makes a difference. So from my end, what you described to me, if someone's trying to sell you insurance, especially with you living up here, it's a scam, huh? And you don't want to get involved, but my question to them would be, where'd you get my number? How'd you get my number? Who gave you my number? But generally, be polite, say, I'll talk to my PCP, and that's where you leave it. But again, remember what I'm saying, pass along the 3 things I told you. If you have government-issued Medicare, you have no payments for any of those 3 things. And what I see so sadly, I have a good friend of mine, right carotid completely blocked. Whole left side of his body wouldn't move. He had surgery. Dr. Lang, only guy in Pittsburgh does it. Bypassed this blocked carotid artery. He can drive again. He moves everything. He couldn't get into rehab. He didn't have regular Medicare. He had a managed care program. You know what they said? Do outpatient first. That's what they said. If you have regular Medicare, my uncle who lives here fell a week ago Saturday. I sent him over to Kennedy, Heritage Valley Kennedy. They called me up. He's on a blood thinner. Hey doc, nothing in the head. Everything looks pretty good. How'd he fall? I don't know. He doesn't look good. We have him up on a walker now, and he's kind of shaky. I said, okay. I called the inpatient rehab unit. He went from the ER to the inpatient rehab unit. Why? He had regular Medicare. No referrals, no authorizations, no nothing. Boom, right in. So please pass that along, guys. I hope you guys never have a problem. And the fact you live here, I don't think you will. But for those friends, family, people that you know, make sure they know the regular Medicare. And then you have to get a supplement to pay for some stuff. I've heard Cigna's a real good one. Check with whoever you get your insurance stuff from. But all you need is what they call Medigap. That's the gap between what Medicare pays for and what you have to pay out of pocket. And all the people I know that have regular Medicare with that Medigap, none of their fees are over $250. And the ones that are up in the $250 have other medical problems. A lot of people are in the $100 range. So once again, please pay attention to that. And I guarantee if you have regular Medicare, no one's calling you, ever. So please pay attention. Any other questions, guys? Yes. Wait. Yes.
When you clone your heart, what age is that clone?
It would be brand new.
Brand new.
Brand new.
All the problems in your heart that you have now, that's the reason you're cloning it, they're gone.
Well, but you would not be able to put the cloned heart into your body yet. You follow me? Right. Like that technology to advance it to the point where it's able to get right into you. The whole point is they're cloning hearts so they can match you. If you want the one for you, costly, California or Oregon, and yeah, they would set you up to be able to get you that heart. So you'd only need the LVAD for a period of time. It's not like it takes 50 years. but the timing of it, I'm not exactly sure of the precision of it. But when it's organ, yes, they make them pretty quick and they can get them into a body.
But then when he did the horses, were they the age of already running, or were they both babies?
Babies, yeah. I think it was, I remember the date, like 2009, and I think they ran their first race in 12, something like that. Yeah, but it remarkable. Look it up because it's remarkable. When you see the polo guy standing, holding 3 horses on this side and 3 horses on that side, and he purposely rode. They said general polo matches that the guy might ride 2 horses. He purposely rode all 6 to prove the point that these horses were great. Yes.
Any idea approximately what these robots cost, like the second?
No, I don't, and it's so cool. My son's an electrical engineer, and when he finished up, he went to RIT. When he finished up, they had to do a project for graduation, and he made a puck. And you know how they have the automatic pass thing in baseball, like throwing? At that point in time, they did not have, in hockey, an automatic puck thing. So they did it as a project, and they sold the patent. The only problem was the school kept the patent. Any other questions, guys? Sorry I was late. It was Joanne's fault.